An application programming interface key is a unique credential that allows a program to access a service or data resource. By assigning specific permissions to each key, organizations control which operations a client can perform and which data it can view. Careful management of these permissions is essential to limit potential damage if a key is compromised and to enforce the principle of least privilege across all integrations. An over-permissioned API key is a credential that has been granted more access rights than necessary for its intended task. Instead of limiting permissions to the smallest set of actions required, these keys may allow full read, write, delete, or administrative functions across multiple resources. This practice violates the principle of least privilege, increasing the potential impact of a compromised key and widening the attack surface for unauthorized access. Over-permissioning typically occurs when developers grant broad access by default, copy existing keys that already have full privileges, or use convenience templates that include unnecessary rights. Teams may skip reviewing the actual operations needed or rely on service defaults that allow all actions. As projects evolve, new resources get added to the same key, and temporary or legacy permissions are never removed. Without automated checks or periodic reviews, these credentials end up with far more access than their intended business tasks require. When an over-permissioned API key is exposed or stolen, attackers can move laterally through systems, exfiltrate sensitive information, disrupt services, or manipulate data without additional hacking. For example, in one incident, a software team committed a default key with full database privileges to a public code repository. Attackers used it to copy customer records and spin up unauthorized computing resources, generating unexpected cloud charges. In another case, a key intended for read-only operations was later expanded to include write and delete rights. Once compromised, it allowed threat actors to erase critical configuration files and force a costly recovery. These real-world events highlight how excessive permissions magnify the impact of key leakage, leading to data breaches, operational downtime, and regulatory fines. Begin by inventorying your keys and comparing the permissions granted against the actual task requirements. Use log analysis and automated checks to flag keys with extra rights, then remove unneeded permissions, create new keys with only required access, establish approval processes for changes, and schedule regular reviews to maintain minimal privilege.